Okay, so we have started with variable declaration, and then looked at the type of the variable. And when you have two different types of variables being added or multiplied, whichever data type is high, the variable is going to take that data type. And then we looked into how to use Python as a calculator, just with normal plus minus star is multiplication and division, slash is a division which gives you the real numbers, and double slash gives you integer outcome. And then there is a mod operator. Mod operator gives you remainder. And then we looked into string variable, an object which is of string. You can create it using a double quote, enclosed in double quotes or single quotes, and this outcome is given by the Jupyter Notebooks console. And if you use print statement, that is actually Python's outcome, which actually considers the special escape characters like /t, /n, and all that. Okay, and then we have seen peculiar behavior in Python. When you try to multiply a string and an integer, it will not throw error. It will actually output like this. Okay, and when you don't use concatenation operator, plus is a concatenation operator. When two strings are need to be concatenated, you need to use plus operator. Even when you are not using plus operator, it is actually concatenated. And then we have indexing and slicing in strings. And same indexing, same slicing will be followed by the lists and tuples and all that other data structures. So I have taken the strings and then try to explain that. Whether you use single quotes or double quotes, the same string object. Okay, and then the index starts from 0 and goes till n-1, and 0 gives you word of 0 gives you the first character, 5 gives you last. There is negative indexing. It starts from the end. This is -1, -2, -3, and so on, -6. So when I said word -1 is giving me n, and word -6 is giving me p. And then slicing. It is like cutting the total string into multiple pieces. 2 to 4 means it starts from 2 and takes the characters till 3, not till 4, because it will not consider the fourth last character as if it considers, right? When you slice and try to join, you may not get the original string, and we can actually do the without any beginning and end. That actually gives you index can be used in slicing also. See, when I sliced and combined, I have got the original string because of not considering the last character. If we consider the last character also, then we sliced, we would have got p by 0, 4, right? So O twice, we would have got O twice in the Python. So when we slice and combine, we should get the same string. Because of that, it was not considering the last character. And then there is a stepping also. When you slice, you can actually step through the second column, and the number here actually specifies how many characters you should be skipping. Okay, and then negative that stepping will actually reverse the string. And indexing will throw error when the index is not present, but slicing will not. So when you are using slicing, you should be a bit careful. When you already know that the string is not that long, you should not be using slicing. You should be using indexing so that it throws error and then you can handle it. Okay, and then we looked into a little bit of compound data types, and the lists we started. If you want to combine multiple values and use them in your program, you should be using lists, and a list can be declared using the rectangular brackets like these. So simple list, and then within rectangular brackets I kept values, 3 values there, and then I'm printing. When I print, right, I can print like this, or in a for loop also I can print. We'll see control flow statements in a moment, and there we'll actually try to understand what's happening. right? How to loop through and all. So simple list, right? And it's a type, it's a list type. And then we can enclose, right, the different kinds of data types. The values of different types can be enclosed inside the list, right? There are integers, there is a string, there is a boolean value. But in C language array or Java arrays, we cannot have heterogeneous data. But in Python list, right, we can have heterogeneous data. And I can actually index, right? I can actually use indexing and then look at it. So let us look at the 0th value here, right? It's a number, right? Let us see the type of it. See that is integer. But when you look at the fifth items, data type is str, string it is. So when you do mathematical operations with different data types, ultimately you get a bigger data types type. Right? Let me try to show you what I'm actually talking about. If I take a is equal to 4, b is equal to 2.5, right? What is the data type? What is the data type of a?
Integer.
2.5
Float.
Right? If I do c is equal to a plus b, these things you can actually do, right? And just out of, for new people it will be good, right? So if you see, the c data type is float because one of the values is float and it is the ultimate variable is going to take the higher data. But in the list side, all different data type values will have their own data types. Integer stayed integer. If you look at the 0, and the first one is integer, second one, right, is also integer, third one, sorry. 2 means third one. And fifth one is string. It stayed as a string only. Sixth one is going to be boolean. So in a list, the data types will not be will not get mixed up. Okay? Heterogeneous data will stay as it is. Why am I explaining this here is, we'll see Numpy arrays, where if you try to put heterogeneous data into the Numpy array, it will actually take the highest, the data type. If you have one string, the total array becomes string. If you have one float, the total array becomes float data. Okay, but in lists it is not going to happen like that. It can handle heterogeneous data as it is. Point is clear, right? When Numpy arrays comes, you need to actually reconnect. Okay, so that is the difference between a list and a Numpy array, and there are other differences also. We'll see. So Numpy arrays and pandas data frames are the ones we are going to use extensively. These are also we are going to use, but we are going to use extensively, and there will be many methods, functions, and all that, classes and all that. So our focus is that we need to learn that. Okay, and then you can use same indexing concepts as we have used in same slicing concepts as we have used in strings, right? And negative indexing is also there, and stepping is also there. This is actually slicing, and then this is stepping, right? I reversed the list by taking the -1. Okay, and then I concatenated two or appended two, concatenated two lists here. This is one list, and this is another list. And on Friday, when we try to add a number to a list, right, it throws error. You see this? Right, it throws error. If you want to add, if you want to append a number at the end of the list, right, you should be saying, right, it will not throw error. Now, if you, I don't know, maybe I should have taken into a variable, and then I think I should take this into a variable and then print it. Rather, it's not outputting anything. Append method will not output anything. Else, I'll show you. Okay? So if you want to add a new value to a list, right, you should be using append method, and I'll show that. Okay, and then the strings are immutable and lists are mutable. Immutable concept is very simple. You here, if you see, I am going into second index and trying to update a value, which is throwing error. That means this object, right? This object is of type string. The class is of type string, and then you cannot modify the values in a string, string object. So like this, you cannot modify. So that is called as immutability. You cannot mutate the value inside the object. But in list, right, you can mutate it. You can actually update a particular index value like this. Okay, I changed the fifth index value and the column to 36. Okay, and then you can do mathematical operations like these in the expressions in the while assigning values also. If star means to the power of 4 to the power of 3. Okay, 4 to 4 cube it is. Not 8 cubes. Okay, so I am inserting a value at second index. Yeah, how many times a value is repeating? Count is a method which is, so insert is there, count is there, append is there. These are all methods present. Functions or methods are similar words, right? They are synonyms. In object-oriented programming, we call functions as methods. Okay, variables as properties. Okay, so there are functions inside this list class, and I am using it. How do I know? I can actually look into the API documentation. This is the API. Did you guys get a chance to look into API documentation? Did you guys went through this documentation and try to play with it?
Yeah.
Right, see the data types and all this, right? You need to get used to this documentation because I think somebody who is from Java and other background, they know, but somebody is new, right? They should get used to this documentation because now we are learning 3.8. In future, you will get 4.5 or 6, or maybe in 2 years it will be 10, and there will be lots of changes. So if we know how to read through the documentation, right, we will be up to date at all the times. No need to be dependent on books or any faculty, okay? any people who actually train. So here append method is appending at the end, and insert method is inserting some value at some place, at some index, and then how many values are present in the particular list is being counted by count method. These all methods are useful when you are doing programming. So length is working on a string and list also. It is actually giving you length of the string. So now this cube became like this. At second index we inserted 1000, and then yeah, count, and they did not do much. That append is actually adding values at the end. Okay. The next thing is assigning values to a slide. Can you see it clearly? Do I need to zoom it? Zoom in better. Okay. So assigning slices to the list. So here I have taken a list here, and then I am trying to slice it, right? 2 to 4. I've got 2 characters there. And what I'm going to do is I'm going to update this slice from 2 to 4 with a 4 valued list, right? See this? Letters of 2:4 is from here to here. But when I updated it is equal to, I said, a 4 valued list. It actually happened, right? So whether it is 1 element or 2 elements, you are trying to update with a bigger slice, you can do that. So how it is happening is, it's a linked list concept. I don't know whether you know it or not. It's a linked list concept where it is just a link, it's so it is like this. This whole thing is like if you take each one as a box, And there will be links like this, going forward and backward, forward and backward. Okay, when we are trying to update from 2 to 4, what we are doing is, what the interpreter is doing is, it is cutting this here and taking this out and then linking it here. Like that. These boxes it is linked. So it doesn't matter whether you have one or two or how many, you can actually update it with a list. And then it became like that. Got it, right? Any questions? Okay. So you can actually empty a list or empty a slice also. 2 to 5 I have taken and I updated that with a blank list, and it actually removed the elements from that particular slice. Okay. And then you can remove the total values inside the list by updating. Yeah.
So here that it will consider the lost index also. You mean to say like in the strings and lists it won't consider the lost index like 2 colon 4. Usually it will take that 2 and 3. You should not consider the 4 index. But here it's considering the 4 index also, right?
No, it is here also considering 2 to 3 only. See this? This is 0th index, first index, second, third.
No. In the 25th, if you see that it is a 2 and 4. So
2 and
means
4,
like,
it actually replaced these two values with these 4 values. That's it. See this? These two values, 2 to 4 means 2 to 2 and 3. Right? It just updated. It actually took out that particular, those two boxes. It is like train, right? It took out those two bogies and then it added these 4.
in that case, if you are not providing that lost
Oh,
index,
sorry, I linked it somewhere. Wrongly linked it. Give me one second. I think I should have linked it at E, right? This link is wrong. Sorry. Here it is going to be. Right? Now it's correct, right?
So in that case, why do you need to give that value 4?
That is how it works. That guy who designed it actually designed it like that. That's a good question. It should have been 3 only, right? So, yeah. But the index starts from 0, right? That's where maybe they are giving a little one more number, right?
Yeah. Okay. Thank you.
So you can update a particular slice, and you can actually update the total list into a blank thing like this. You can remove also. Pop is there, and other methods are there in the API which actually do different things. Just practice them. Okay. So with that, right, I can actually say the lists are over. So here I have taken one simple example. This is like this is for future purposes. I actually kept it here. So this is like I have taken a list A. Name it differently. List A and B, and then I am creating another list which is comprising of these two lists A and B. Now I am enclosing A and B inside rectangular brackets. That means list of lists it is. See this? This is a big list. Inside it we have two lists. Okay. So this is like two-dimensional array. Okay. If I try to, why am I explaining this here is again in Numpy arrays we'll see this. Again we'll see how lists of lists can be created as matrices in Numpy arrays. So this can be represented like this: A, B, C, 1, 2, 3. That is one list. This is another list. Now it is like two-dimensional array, right? 2 rows and 3 columns. If I have to access this particular value, this row index is 0, this row index is 1, this column index is 0, this column is 1, this column index is 2. So if I have to access this value, right, x of 1 comma 2, I should be saying like that. See this here? We are not going to use this kind of a structure in our program. We are going to use Numpy arrays, but I'm just introducing here that you can create as complex matrices as possible. So this is actually a two-dimensional array where you have one-dimensional arrays as rows inside another matrix. If you want to create three-dimensional array, right, it's going to be like this. So you will have a two-dimensional array like that, which is enclosed with multiple one-dimensional arrays. Okay, and then you will have this kind of array, one more array behind it, like that. Okay, and then it is enclosed inside another bracket. So that is actually three-dimensional. So this is one two-dimensional array, this is another two-dimensional array, third two, like that. Many two-dimensional arrays will be there, which are enclosed inside one more bracket. That becomes a three-dimensional array. This is Numpy arrays structure. Even pandas cannot create, but Numpy array is multi-dimensional. If you want to create four-dimensional, right, you will actually have three-dimensional arrays, multiple enclosed inside one more bracket. That's it. We'll talk about it again when we encounter the Numpy arrays, but I tried to show simple example, a two-dimensional array here. Got it? Any questions? All right.
Nora.
Yeah. Because whatever we are seeing here is all with the purpose we are seeing. Okay, and try to practice and remember, because now we are going to. I am going to talk about these again in the future classes. Okay. Give me 1 second. Give me 1 second. Okay. So here I try to access this value by saying 1 comma 2. So there are two rows here and one column kind of structure. It's a list, the nested list we call it. Generally, we will not use nested list. We will use Numpy arrays, but for knowing, so you can create list like this also. But inside, this list is a method which actually takes the list and creates, or any other data type also it takes and converts. So we'll see that in a moment. And then I'm appending these all things, empty list can be created like this, or like that also. Just rectangular brackets will also create empty list, or the list method will also create an empty list. It's a constructor basically. Class name would have been given with small, starting with small character. I don't know why the list is a small letter. Okay. Then another compound data type is tuple. To create a tuple object, you just need to send the values with the comma separated values to a variable. So tup1 is a variable where you are actually putting comma separated values. Automatically it will create a data structure like this. So in the list, right, you actually need to enclose the values inside rectangular brackets. But if you just pass comma separated values to a variable, it will automatically create a tuple. Why this is useful? In Java or any other language, if you are getting some data which is comma separated, to create it into a data structure and play with it, you may have to write multiple lines of code. These guys, Python guys are actually trying to reduce that code. You have some comma separated values and you just assign them to a variable, automatically it created a structure. It created a data structure. We call these as data structures. Okay, so can we do indexing? Can we do slicing? Yes, we can. This is also heterogeneous. It can also handle heterogeneous data, but tuples are immutable. Unlike lists, tuples are immutable. You can do indexing, you can do slicing. These are all common between the tuples and lists, but only peculiarity or difference is that you cannot mutate. Index value is what in this 13. I am trying to update that to 40. See, it is actually showing exception. Tuple object does not support item assignment, but lists we were able to change, right? Some value to another, right? When by accessing the value using that index. Tuples are immutable. Strings are immutable. Tuples are immutable. There is a concept called unpacking and packing. Right? This is called as packing. When you pass comma separated values to a variable and it creates a structure, that is called as packing. Okay. When you take different variables and then try to assign your tuple, that is called as unpacking. There are 3 values inside this tuple. I need to give 3 variables. And first value will be assigned to A, second value will be assigned to B, third value will be assigned to C. See that? If I give one value less, one variable less, you throw error. Too many values to unpack. There are 3 values inside the tuple, but we have given only 2 variables to hold. Right? The second variable can hold only one value, and it is trying to pass 3 values. So you need to know to do unpacking. You need to know how many values are there in the tuple. So how to know how many values are there? Len will give you how many values are. Then you can create maybe another list and then assign or whatever. Right? Unpacking. When you know already that a particular method is returning this many values, and you know that it is already then you can actually do unpacking. This is useful. The terminology is what I am trying to introduce here: packing and unpacking. Because when you read through articles and try to understand the documentation, this is the same terminology. Any questions here on tuples? Any questions? Good. Okay. So the next thing is set. Okay. Somebody who is familiar with Java, right? They will know that sets cannot handle, or sets will actually eliminate duplicates. See this here. I declared a data structure using curly braces. Okay. We are trying to understand different data structures. They are all useful in different places. If you want to, you have some values and you want to create a list, you can create it using the rectangular brackets. And when you create lists, when you want to update them, in real time, while program is executing, you may update the values. Then you create lists. You don't want to update the values. Then you create tuples. You want to eliminate the duplicates. You want to create a set. So different purposes, different data structures. You can actually transform one data structure to another data structure. Okay, so here I have taken a basket, a variable, and I have taken a set in rectangular brackets. Right, there are some strings like apple repeated twice, orange repeated twice. Right, nothing else repeated. So I created, and if it is a list, right? If it is a list, this is list, right? The rectangular bracket, so it is list. So everything is intact, right? Apple is twice and orange is twice. If I change these rectangular brackets to a curly braces, see, duplicates got eliminated. Apple only once, orange only once, right? The set data structure eliminates duplicates. If there is a requirement, there is a functionality you need to implement which needs to eliminate duplicates, right? You can use it. But the point we need to remember is set is an unordered list. See this here? I passed apple first, 23 next. But the output list did not maintain the order. But if it is a list, right, it will maintain the order. See that? Whatever you passed in the same order, we got the output. But in sets, it will eliminate the duplicates, but no, it will not keep the order. It is like you writing a program. You try to see whether the apple is occurring one more time. You are removing it. So in an order, it is not actually once after doing the elimination, right? The order will not be maintained. Okay, so that point you need to remember while writing code. So you can create an empty set by using set constructor like this, set and method, not like this. Why am I explaining this? Why am I telling this is, if you want to create an empty list, right, you can create it like that, or you can say like that also, right? But in sets, right, this should not be used. This is used for creating dictionaries and other data structure, not sets. Okay, this is not valid. This is not valid. This is valid to create an empty set. Okay, and then when you pass a string to a list or set, right, it will actually become like this. Each individual element will come. See this here. If I put list here, see that all the characters inside the string have become individual values in a list object. Okay, see this list here, and duplicates were not eliminated. But if you say set here, duplicates will be eliminated. See that? Duplicates eliminated. Only space came once, and A came once, and C came once, and all. So it depends on the requirement, what you want. And then sets can be used for set operations in mathematics. Mathematics, there is a set operation. We use it to do Venn diagrams, right? A minus B, A and B, A or B, right? Union, intersection, right? Those operations can be done, performed with sets. Okay, so A minus B means all the elements in A, but not in B, right? What is A? A, C, D, R, B, and space. And in B, we have A, right? We have C. So from this, right, we are going to take out A and C. L is not there, Z is not there in here. See this? A and C were eliminated, so you got B, R, no, D, R, whatever. So order is not maintained. See this here? In this set, the order is like this: A, C, D, R, B, and then a space. When I do A minus B, it should be eliminating these two values which are present in the B and give me D, R, B, and space if it is maintaining the order. Right? If it is not maintaining the order, see this here? It actually gave me space first and B next. So you should not be expecting the order. So that's the point you need to remember. This is like eliminating the values which are present in A and also present in B. A minus B. A or B, it is like union operation. Union means it takes all the distinct values from A, distinct values from B, combines and creates a new set, right? And then A and B is like intersection, right? Intersection is going to give me common values from both the first set and the second set. And A cap B is going to be A union B minus A intersection B. A union B means all values. A intersection B minus this one. If you eliminate only A and C from these values, right, it's going to be this. A cap B is letters in A or B, but not in both. The intersection area we are going to eliminate. Got it? That is sets. Any questions? Any questions? Good, right? Can I move on? So I'll stop after this dictionaries, right? Dictionaries, and I'll show you simple example of using all these different data structures, and then stop. Okay. So you need to practice, and if you want to practice live here, right, we'll be here to help you. Keshav and me both are here. So dictionary is another data structure. So for all of these, right, there will be more documentation, more methods. You can do many operations there, and you need to look into the documentation. Okay. So I've given links in there in our code file. You just go through those links and practice. You will have to practice a lot. When machine learning comes, right, machine learning statistics comes, right, we will be doing more work than you. But initially, you should be practicing. No, bottom line is if you don't practice, you will not get. Okay, you need to practice a lot. So dictionaries can be created like this, with the curly braces only we are creating, but so this is actually set. Okay, this is set. Sorry. Dictionaries also will be created with curly brackets. When you create use just the curly braces, right? You create an empty dictionary. See that? The type of this fruit calories, mapping. So dictionary is a data structure which actually holds key and value. Apple has got 95 calories. Orange has got 2 calories. So if you have some key and value pair and you wanted to create a data structure of that, you should be using dictionaries. Dictionaries are very useful. In many places, we'll use them. Okay, so I created a dictionary here, fruits dictionary, calories dictionary, and then I am trying to print it. And then fruits calories of mango, I said 202. Mango will have 202 calories. When I don't have this particular mango key in the dictionary, it is going to add a new value in there, new item we call this. This key value pair is an item. This is one item. This is second item. When the mango key is not present, it added a new item. See this here, mango. Right? If I want to update this mango calories to 120, I should be taking mango and then saying 120. So now I print it. See, let me print it on the top. See that? The value changed. Right? It is 2. When I updated, right? Executing the top cell also is changed. It is actually in the memory. So wherever you update, it is going to change. Got it? So you can print it in the below or above. Whatever. So escape A and then two cals. So to print the values right now. So when the key is not present in the dictionary, it is going to add a value. The key is present, it is going to update the value. That's how it's going to work in the dictionary. Okay. Any questions? Good, right? Okay. Then you have 2 methods inside. There are more methods. If you look into the dictionary, API documentation, you will see all the different methods present in the dictionary. But here I am showing you a sample of 4 methods here. So keys is a method which actually gives you all the key values as a dict keys, and you can convert this into list. See that? This particular dot keys method gave me dict keys object, and I'm converting that to list. So now you can play with whatever you wanted to do, you can do it. Okay. And again, now you can actually loop through. We'll see the control flow statements tomorrow. And values is a method which actually I am saying a method or a function, right? If you don't use the brackets after the whatever, right? You call that as attributes. If you use brackets, right, you call that as function. Okay. So values is a function which actually gives you only the values. And you can actually loop through that also. For loop. I said that each of the key value pair is called as a item, right? This is one item, this is the third item, this is first item. So to access items, right, you have items method. Dictionary dot items will give you all the items inside a dictionary. And then you can loop through also. Here, if you look at it carefully, dict items object is a list of tuples. This is list, right? And then this is tuple and comma tuple, comma tuple. When I say tuple, right, brackets will be there, enclosed. The values will be enclosed inside. In it, can have many values, but dictionary will have only value pairs. So in each tuple we have only two values. Okay, and items is a method which actually gives you access to each tuple. When I am getting tuple here, right? Items is giving me tuple like that. I need to unpack this tuple, right? What is unpacking? When there are two values inside a tuple, you should be giving two variables. See this here? A variable for key, a variable for value, right? The first, in the iterations, it will get the first tuple. The key is assigned to K, the value is assigned to V, I'm printing it. Again, the next tuple will come, the key is assigned to K, value is assigned to V, printing it. The key is assigned to K, value is assigned to V, printing it, like that. Got it? Key value pairs. When you actually call items method, it is going to return list of tuples, and to handle each tuple, right, in a loop, you are taking one value at a time from list. That's where I actually kept this and I forgot to explain this. Right? Whether you use values or keys, there will be multiple values in this, and each value you are getting to V, printing it, getting into V, printing it, getting into V. But in here, it's a tuple. Each time you are getting, so each tuple is unpacked, printed, unpacked and printed, unpacked and printed. Got it? Any questions?
So in a dictionary, we can't use any index, right? Index value.
No, we cannot.
We should use
No.
with we should retrieve the data using the key value and
Key only.
key.
Like
Okay.
no indexing, no indexing. If you want to use indexing, right? Maybe you should convert that into list of tuples, right? List of tuples, and then you can use indexing. See this here. This is actually so somewhere. Let me try to convert it into list. So here, right? This is items is giving. I think I can convert dictionary also into list. Let me see. See that? When I converted the dictionary into list, right, it actually gave me keys only. But if you try to do this root calc items, right, you will get, see that list of tuples with that. Now you can use index, right? If you just say here, bracket 0, you will get first. So, see that? Got it? Getting it? Right? I converted this dictionary, the values inside the dictionary, items inside the dictionary into a list. Now I can use index. Sometimes we'll get those situations where you may have to know the particular index of the value inside the item inside the dictionary. Then you need to convert it like this and then use it now using the index. Got it?
Okay. So if we convert into tuple, we can't change the data, right? In that tuple.
You want to convert it to list, right? Again, you can convert it like this.
Okay.
You want to change values, right? And again, you are getting individual values here. Individual values, you can actually do it according to its data type. Here, Apple is a string. You cannot actually change this P to something else. That is immutability. But you can change the key altogether. The key, right? Altogether, you can actually alter the key. No, you cannot alter. You can actually completely change it. Apple to maybe mango or banana or whatever.
Okay.
Key you can change.
Okay. Thank you.
So, Ramaraju, I have one question here. See, every dictionary is converting it as a tuple, right? So tuple in the sense like it will consider each item separated by the commas. So here Apple is 1 is 95 is 1, right?
No, when you see the brackets like this, right, that means it's a one object it is. You shouldn't be seeing, you should see.
So now I'm trying to convert it, this data as a tuple. Then how do you get that key and value? Because how it knows that it is in key and value? Tuple is everything is an individual value, right?
Okay. So yeah, that question is right, but let me try to explain it. If you look at these items, right, if you look at the outcome of the items, what you can see here, I can see that as a list, right?
Yeah.
And inside it, I have one tuple, second tuple, and third tuple. Okay. In a for loop, right? Let me try to show this. Let me try to convert this whole thing into list. See that? Now this is a list of tuples, right?
Yes.
Right?
Yes.
Do you agree? Now if I write a for loop, what happens? In another language, for loop, what it actually does? I in I'm trying to explain, but I don't know whether I'll be making sense or not. Right? If I don't make sense, just will repeat. Right? See that? What I got? When I took the items inside the dictionary, what are those items? They are three tuples, right? Right?
Yes.
Do you agree? Till this part you are good, right?
Yeah, I'm good here. There's only I'm confusing with because tuple is immutable, right? But we can change the key and value. But
No,
internally, it's converting as a tuple inside the list, right?
no. You can actually change this whole thing. When it is a tuple, right? You can change the total thing, but cannot
Hmm.
change the apple. But if you convert this into list again, right? You can change it. That's what I said. Maybe my statement is wrong, or maybe the way I expressed is wrong. Your point is right. I cannot change apple to banana. That point
We
you're
can
wrong.
change the value. We can change the value, right?
You can actually change the whole thing, that whole, right? You can actually remove this and update, or like this. I'm trying to do it like let me try to do this. If I of 0 is equal to apple, I will be going into some other area, but let us see. Then what I want to do is I wanted to take another tuple, right? I wanted to print. Right? I'm just printing here, but you can do that. You know, so you can actually do like that, or you can actually update your that dictionary also. You take dictionary object in the top, and in a loop you update it instead of printing it, because this whole thing is a list, and inside a list the objects are mutable. You take a particular index and you can update it. Let me take another dictionary here and then try to show you. ACT dict2 is equal to, right? So maybe we take yeah, and then dict2 dot items, and then dict2 of 0. No, not dict2. Here I need to take an object like this. I think list lst. Don't get confused, okay? So I'm just trying to answer the question. I'm trying to correct maybe my statement. Maybe my statement is wrong. Else do nothing, right? Do Okay, cool. Now, What? Oh, sorry. This is already. Got it? What I did here, I actually took the dictionary, a copy of the dictionary, and then converted that into a list of tuples, right? And I am updating list of tuples, and the outcome is list of tuples. Again, if you want to convert it into dictionary, right, you need to actually do this like this. Dict 3 is equal to, give me one second. Give me one second. Give me one second. Dict 3 is equal to dict of list dicts. Again, I am converting that into dictionary. Now printing dictionary. See that this is dictionary, the structure is different. This is list of tuples, this structure is different. If you want to update, right, if you want to change a particular one, you can remove it and add it on. Items can be removed and added, but you know, when you are transforming from one structure to another structure, also you can do. Yeah, go ahead with your question.
So now, if I want to change the banana value, for example, here ls underscore dict2, here we are providing the 0 index. Instead of that, we can provide the key, right?
You wanted to you can say provide the key, but value can be updated. Key cannot be updated.
The value can be updated. In that case, if here tuple is immutable, then how it is going to be updated?
No, I did not do the total tuple I updated. See this here? Apple, right? If you look at this, Apple and 95 is one tuple, right? I updated total tuple. I did not update just the value there. Got it?
Okay. Yeah, got it.
Right?
Okay.
Total
So
tuple I
enter
updated.
memory and it will create the new memory.
Entire item I am just replacing.
Yes.
Apple item, Apple key value total entire item I replaced.
Yeah, got it.
That too, that too after converting it to a list and then
I got it. It's clear the memory. It will create the new memory for
new one, new thing. Altogether a new thing. Replace. Okay? So don't get confused. This is all like not a big deal thing. So items is a method which actually gives you the that tuples, and tuples can be unpacked. So that's where we are actually taking two variables here. Two variables separated by comma. Two variables separated by comma, which will take first value and second value. First value will be given to key. Second value given to value. Right? This is key and this is value. So items will be tuples. Tuples are unpacked and then printed. Okay. So dictionary can be created in different ways. Dict is a constructor again, and you can pass list of tuples like this. This is list, and then tuples, tuple, right? That will create a dictionary, and you can create dictionary with the key is equal to value. Key is equal to value. Keys. So in dictionaries, the keys must be immutable. Right? The key whatever the number you are taking, you cannot take a list as a key. See this here? Let me try to create this way. 2, 3, 4. If you look at this, right? This is a key. This is value in a dictionary. Let me see the unhashable type list it is saying. So the key cannot be immutable object. Key should always be mutable object. Either a tuple can be taken as key, or string can be taken as key because they are immutable. Got it?
Yes.
So there is one more concept as a list comprehension. Okay, suppose that there is a set like this. Maybe let me take everything in list. No. That's okay. Suppose that there is a list like this, and I wanted to have or output only the items which are present in this list, but not in this list. I can do set operations, right? But to explain you list comprehension, I am taking this example. The requirement is like this. There is a list and there is another list. I wanted to see whether value of this list is present in present in this list or not. Any of the values in this list are present in this list or not. If any of the value is present, right, I want to eliminate it. If not, right, I want to keep it. To do that, I need to write this much of code. I took empty set, and then I'm saying that no present or not, right? Not present I'm taking, and then checking whether this value, right? I'm taking the value into x, and I am taking this value into y. I am checking whether x is equal to y. If x is equal to y, I am saying present is equal to true. If present is equal to true, I am not adding. If not present, then only I am adding it to this empty set. Got it? Ultimately, I wanted to take only the values which are present in this, but not this. This is the logic. So I took this present as the flag, which is actually being assigned to true when we find it in the second list. Did you got that logic? Any questions on the logic part? Guys, any questions on the logic?
Yeah, I got the logic, but here thing is like 1, 2, 3 duplicates are there, right? So we can eliminate the duplicates using convert into both the array into those list into the set, right?
Yeah, we can, but I took a junk example there, just to explain that.
But how do you convert the list into the set?
You can do it, you can actually put the rectangle, the curly braces here, or you can actually pass, these values to set. Right?
Okay.
You
That's
can
it,
do
right?
that.
Yeah.
So you can practice, you need to look into API and practice, right? So this is the logic. In any language, C language, Java language, C++, any language, you should write this much of code. But in Python, we have very simple way of doing it. Okay. So let me take this also as rectangular brackets. This is called as list comprehension. What we are doing here is for x present in that list, if x is not in this list, right, then only I am taking it into x. So it is like an SQL query. It is like an SQL query. Select x from 1, 2, 3, 4, 4, 4, and so on, maybe 7, where x not in 1, 2, 3. Right? This is a SQL query, right? Right? What's happening here? Take values from this list when the value is not present in this list. That can be written as a list comprehension. So when you are looking at list comprehension, right, you should be looking at that part separately. Right? For x in this list, we'll get 1 into this, right? This one value into this x, and then it will go here and check if x is present in this or not. The condition is not in. Okay, not in is false, right? Not, it is there. 1 is already there in this list, right? So it is false. So it is not going to grab it into this x. Again, 2 will come into x, and it will check whether 2 is present in this or not. It is present. So again, false will come. It is not in. So it is not going to grab into this x. 3, it is not, it is there. So it is also not going to come into x. Now 4, right? 4 came into x. 4 is present or not? It is not there. So it is true. The condition is true. So the 4 is going to come into x. Okay. Again 4, it is going to come into x. Again 4, come into x. 4, 5, 6, 7. So the x will have all the values which are not present in this. See this here? So I have actually, taken a set there. That's where it eliminated duplicate. But if I take a list there, at the outside, the outside component, right? This outside, whatever the bracket, it's a list. So I'm getting a list here. If I make it a set, right, it will eliminate all the duplicates. So when I took list, what happened? It took x 4. It is not there. The condition is true. So it captured here. again 4 captured, again 4 captured, again 4 captured, 5 captured, 6 captured, 7 captured. Right? The total enclosed bracket is rectangular, so you are getting a list there. Okay, if a total enclosed bracket is that, right, it's going to eliminate duplicates. Got it? That is list comprehension. Instead of writing this much of a program, you can just put it in a list comprehension like that, and it will actually do that whole operation. Got it?
So to represent a list, do we need to definitely use braces, or else can we
Rectangular
use
bracket.
a rectangular bracket, or else can we use something like list of x for
Yeah,
something like
that
that?
also you can do.
Okay.
But here in the list comprehension, you cannot use list of. I think you cannot do like this. I think. Let me see. That's a good question. I never tried. Oh, we can do that. We can use that list of also.
Okay.
So generally, list comprehensions are little like this, and I never tried. That's a good question.
So is it only for list? I think you just
Yeah, you can
give an
set also.
example for set as well. For tuple, I don't remember. Tuple and
Tuple also, I think. Tuple also we can do. I never tried. Let us try.
okay.
No. Everything can be listed here. Everything can be set. Right? And then tuple also. You can do it tuple also. It's giving a generator actually. I'll talk about generators later. And it's a different kind of method, a different kind of function, the generator. The output is a generator. I'll talk about that later when you actually use tuples, right?
Okay.
I never experimented this particular part.
Thank you.
Generators I'll explain that. And then you can create a dictionary also as a list comprehension for x in whatever I am actually saying x colon. So you have some data structure there, and then you have some expression, and then a for loop. Right? That is actually creating that particular. So 2 square, 3 square, so 4 square, 6 square. So it's a dictionary with the 2 and square, 2 and 3 and square. So you can actually access. If you say, squares of 2 will give you 4. Squares of 4 will give you 6, like that. So you can dynamically create dictionaries like this. I never used, but you can do. List comprehensions can be used in creating dictionaries also. This whole concept is called as list comprehension. Okay. So I would say that's it for today, and you guys